Hi, I'm Vignesh, founder of Vistrux. I help engineering firms cut drawing time, thereby increasing their output and their revenue. I spent months building this MCP server, which connected Claude to AutoCAD. Let me tell you this, when it drew the first circle inside AutoCAD, I was so impressed. It was like seeing like your own kid walking for the first time. But there was one catch. It only worked 90% of the time. I thought it was great, but when I pitched it to other engineering firms, they were terrified about that 10%. It took me a while to understand what I was doing wrong within my workflow. But once I understood, I shut it down and rebuilt everything from scratch. So, by the end of this video, you will know where and which AI approach fits your situation. If you are a principal or a senior engineer, you'll know exactly where AI moves the needle for your output. If you're a CAD manager, you will know which AI approach fits into your structured drafting workflow. And if you were like me before, an early adopter, you will know why your experiments felt patchy and not 100%, and what you might try instead. This is what we are going to cover in this video. The two types of AI workflows and what separates them. The ideal use cases for each type of workflow. The framework which I use to create workflows which are reliable and easy to use. Let's get started. In order to understand what I do, why I do it, we need to go back into history. Just like I said in the start of this video about my MCP server. Okay, the MCP server that I had, it basically connected Claude to AutoCAD. Now, this was the post which I did on LinkedIn, showing how it actually works. Now, the thing was, it only worked 90% of the time. Yes, I actually tracked it. I tested. I'm an engineer by trade, so I used to track everything that I do. When I was pitching it to firms, what happened was they were actually worried about that 10%. Now, for a very risk averse and risk sensitive industry like construction, that was a lot. So what I did was I shut it down and I rebuilt my strategy. When I was rebuilding my strategy, I kept four pillars. One was reliability. It had to be reliable. It had to be consistent. It should be easy to use, and it should be scalable. Now, as a general rule of thumb, if you know your boundary conditions, if you know your variables, it is a candidate for standardization and then automation. In, for example, if you don't know your boundary conditions, you need to go back and get your boundary conditions where it fails. What are the edge conditions? So on and so forth. So once you get that, you know your boundary conditions. If you don't know your variables, you go like, what are the different variables that's involved? It could be A, B, C, D. I think that's a bit of a jargon for you. Let's get to an example. Let's take a stair section. Now, this is I've got like a typical stair detail here. It's got 10 different variables like the stair thickness, thread, Rio 1, riser. You can see it here in this diagram as well. And we have got the boundary condition as well. Now, for this specific type of stair, these are the boundary conditions. This is how the stair will be. What are the boundary conditions here? The number of steps could increase. The landing thickness, the landing might not even be there sometimes. So that sort of thing. So we, in this case, we have our boundary conditions and our variables. But here's a very easy way to think about it, okay? Boundary conditions and variables are nothing but the exact same information that you need to make this stair. You cannot make this stair without any of these information. If I don't tell you what's the thickness of the stair or the height of the riser and width of the thread, you wouldn't be able to make it either. All we are doing is sort of putting everything into paper, I'd say. Okay, these are the variables like, say, thickness, riser, thread, and then the boundary conditions, the number of steps, if there's a landing or not, so on and so forth. So that's what basically the rule of thumb check is. So now we have decided stair is a candidate for standardization and then automation. As I said, known variables, known boundaries, the automation is inevitable. The only question is which path? Now we have got two paths here. Path one is where it looks exciting. This is all the flashy stuff that you see on LinkedIn. I see it on my LinkedIn feed every other day. Is where you connect your Claude, or as in which I did before, which is a probabilistic model, and connecting it to AutoCAD. Now, path two is what I say is right for your business. That is agentic workflows, and it is deterministic in nature. I'll explain probabilistic and deterministic later in the video. Going back to the MCP server, my MCP server was a set of tools designed for Claude to use so as to execute a specific task. Let's take draw a staircase as an example. Now, draw a staircase, if I ask my Claude agent to do it, Claude is going to call tools. Now, what are these tools? Tools are drawing a line, offset, add a text, fillet, and I had 100 plus tools like that. Now, when you say Claude, hey Claude, draw a staircase, Claude would think, okay, the riser, in order to draw the riser, I'm going to call the draw a line tool. In order to or do the thread, again, I'm going to call draw a line tool. After that, you use the offset to get the stair thickness. I need to add the text for Rio 1, Rio 2, etc. So you get the gist. Now, this is not any different from how you work. If I ask you to draw the same stair here, you would follow the exact same steps. You're going to use the line command. You're going to use the offset command. You're going to use add text command. You're going to use fillet command. That's it. Instead of you, it is Claude agent which is doing all of that. Now the thing is, Claude agent, just like you, reasons through each command, uses line, offset, text, and dimension, but it consumes thousands of tokens per task. The same energy which you use in your brain, Claude now has to do it. And when Claude does it, it is going to consume tokens. Let's get a bit more deeper into the probabilistic model. What does probabilistic model mean? Given a sequence of tokens, the model calculates a probability distribution of what the next token should be. That's a lot of jargon. I copied and pasted it from Gemini. I'm going to be very honest here. It's the textbook definition. Now you might be thinking, Vignesh, what does that even mean? I love Office, by the way. You might find a couple more of these GIFs here and there. Here's the easiest way to think about it. Let's put again a situation. Hi, I am Dash. The context is me. Let's say there are only three possible answers over there. One is Vignesh, one is founder of Vistrux, the other one is Menon's son. Now the answer here depends on the context and previous token. Token here meaning text. So the answer here would depend on the context and the previous token. Hi, I am is the previous token. So what's the context here? The context would be, am I introducing myself for the first time? If yes, hi, I am Vignesh. If not, am I meeting a potential client? Hi, I am the founder of Vistrux. Am I meeting my dad's old friend? I'm going to say, hi, I'm Menon's son, right? I wouldn't say I'm Vignesh because he wouldn't care. But if I say I am Menon's son, he would understand. Ah, Menon, yeah. So that's it. That's what probabilistic model means. So it's guessing what's the most probable next text or token. Here's an exercise to try. Open your ChatGPT, Gemini, or Claude, your favorite model. Ask it this question: which is the most beautiful city in Australia? You might get one answer. Keep it over there. Open another chat. Ask it the same question. You're gonna get another answer. Now ask three more times. Now compare those five answers. When you compare those five answers, what you will see is the core answer will be the same. It could say, oh, Sydney, Melbourne, or Brisbane. Or what do you like? Do you like more sun? So you might like Brisbane more, something like that. The core answer will be the same, but it is never going to be word for word. If I ask you the same question five times, you're going to give me a similar answer, but never the same answer word for word. Now, you're going to say, Vignesh, what does all of this mean for my business? That's what I have here. Let's just say currently, the same stair. We're going to go back to the stair automation before. Currently, for you to do the stair design, it takes 30 minutes, and to draft the stair, it takes you 30 minutes. So total time, 60 minutes. After doing this automation, let's just say you're going to use LLM agent to do this automation or this workflow. Your stair design is still 30 minutes. Your stair drafting is 5 minutes. Total time, 35 minutes. But the downside is only 9 out of 10 of your stays would be correct, as in 90%. But 1 in 10, sometimes the donut spacing could be different or the wrong fillet. And you'll know which part of that 90 or 10% you're going to be once you start the job. So if a builder asks you to design a stay, do you quote for 60 minutes or 35 minutes? Pause the video and think. What would you do? I hope you pause the video, and if you are like most of these firms out there whom I spoke to, all of them would say 60 minutes. If you say 35 minutes, good on ya. I think I should have met you a couple of months ago. Looks like we didn't meet. So, and 90% or most of these businesses would go with 60% because 9 out of 10 again would sort of feel like 50-50 at this point. I'm going to compare it with the four pillars. Reliability, it failed. It didn't I wouldn't if I can't quote it with confidence, it's not reliable enough. Consistency, it failed again. Sometimes I might get the donut spacing wrong, or I don't know, the wrong fillet, wrong lines or something. But ease of use, pass. Scalability, pass. Ease of use, it's so easy. It's like talking to me. That's what my idea was. Empowering every AutoCAD user with the power of English language automation. And scalability, again, it's there because if you think about it, if you have like a prompt set up, you can easily scale it to 1 or 100 users. This is not to say LLMs are stupid. LLMs are not stupid like Claude and ChatGPT. It's just the wrong use case. You need right tool for the right job. It's like asking Picasso to be a factory worker. He can for sure do it, but is it good use of his skills? Now, this is where LLMs like Claude, ChatGPT, and Gemini shine. Do you want to read your contract specifications? Do it. If you have like a product library and you want to search through it, for example, you might have a sealant documentation. You would have like 50 different sealants and you want to think through which one to select for your project. Great use case. Making sense of unstructured documents. We all have that. We have got this library of 1500 documents and we don't know how everything connects. Use this. RFIs, scope gaps, construction documents, amazing use case. That's where you need to use. The mistake is not using AI, it is using a reasoning tool for an execution job. Now let's go to part 2, which I think is right for your business, which is agentic workflows, which are deterministic in nature. I think you might get it now itself on what deterministic means. Let's just say simple example of a deterministic example would be open up your Excel and you put two variables A and B and true and false. Okay, now this cell, if you put like your if statement, if A is greater than B, print true, or if A is less than B, print false. That's it. That's deterministic. And this is what agentic workflows deliver. Now, remember, going back, what I told you, you need to know these variables, right? And you need to know your boundary conditions. Now, interpolate with this example. Now, you know all of your variables, you know your boundary conditions. How it works is basically you use AI to build the system once. Oh, my bad. I think I should get rid of once. No, you need to test it. You use AI to build the system, to test, you iterate, and you make it better over a course of time. And then you use code to run it deterministically. So there's only probability at build time, but not at runtime. Again, Vignesh, what does this mean for my business? Okay, let's go back to our stay example. Currently, your stay design takes about 30 minutes. Your stay drafting takes 30 minutes, total 60 minutes. But after that, your stay design is 30 minutes, but your stay drafting is 5 minutes. Total is 35 minutes. But you don't have to think, oh, it works only 90% of the time or 10% of the time. It doesn't matter, but because it works 100% of the time. So if a builder asks you to design a stay, you are going to quote for 35 minutes. These numbers are made up, by the way, but I hope you get the gist. Let's go back to our pillars: reliability, consistency, ease of use, and scalability. Reliability, pass, right? If you're coding with confidence, consistency, it's always there. Once you test it, once you make sure you go through your boundary conditions, 100%. So you're gonna get consistency. Ease of use, pass. Again, the only difference here being the way how you work. End of the day, when you're using an LLM or just use an agentic workflow, it's pretty much the same thing. You're still just talking to the agent. Scalability, again, pass, because at this stage it doesn't matter if it's like 1 or 100 people. You are going to multiply yourself, I'd say. Now, how does it work? That's where this set framework comes in. Now, Vignesh, what is set framework? Set framework stands for nothing but standards, as in standards or skills. E for engine, which is Claude, Gemini, or whatever, and T, tools, which are Python scripts in our case. Standards and tools are basically folder structures. All the standards are going to be in this folder, all the tools are going to be in another folder. And you use this engine to build the automations. So what's in standards could be your drawing templates, your layer naming, your firm-wide rules on how to do ABC. For example, you could have another standard setting up architectural to structural. I've actually got a video in the channel as well. Then tools could be set up underscore drawing.py. So for this standard, it's going to read the standard, oh, okay, how to do something, and it's going to call these tools to do that work. Similarly for a stay example, it's going to have a tool called stay.py. So when you say, hey, create a stay, it's going to read the standard and call the stay.py tool, and therefore you're going to have the stay detail. Similarly for pad footing as well. So this is like an example. I've done pad footing, setup drawing, all that in the channel. So if you are interested, go ahead and have a look at it. This folder, it is specifically kept in different folders. I'll explain it in a bit. And the engine is like you use it to build your automations, and the engine reads your standards and then makes sure, oh, okay, I know which tool to call, and goes ahead and uses the tools folder to call those tools. And finally, you have your product in front of you. As I said before, it doesn't matter. It's like 1 or 100 automations. You're going to get the same reliability, same consistency, and anyone on your team can run it. Here's a very easy way to think about it, just to take it home. Let's just say without the set framework. Consider there's a builder and he doesn't know where to use each tools, right? Like if he's gonna have like hundreds of sheets, papers here and there, just like this dude right here. So many papers, tools, he doesn't know where to use each. He doesn't know which standard to follow. And he is, remember this, reinventing the wheel every time he works. Then imagine, okay, if he wants to get somebody new, it is also difficult for him to train someone new because he doesn't know where the standards are, he doesn't know what tools to exactly use. It is confusing. Now, with set, this builder knows where to use the tool. Okay, he's got clear documentation. He's going to say, okay, for in order to set up this framing, you use this drill bit, this screw, there you go, you drill it in there. And he would only be starting from scratch for newer workflows. If there's something new that he encountered, now that's a new workflow. Otherwise, he just refers back to his standard. Okay, I've done this somewhere. Here's the standard. Here's how I do it. And this is how I'm going to do it. And it's easy to train. And there's an effective knowledge transfer. He gets somebody new. He's like, hey, go ahead and use that standard. Or let's just say there's someone in his team he wants to train on. Like I said, effective knowledge transfer. He's like, hey, look at this document. This is how it works. I think we have a verdict. Probabilistic tools are for thinking. Agentic workflows are for delivering. Agentic workflows built on set framework, you're going to get reliability, you're going to get consistency, and you have a system that scales without depending on one person. It also helps you increase your drawing output and therefore increasing your team's capacity. Now, that being said, I have like few thoughts to share. I speak from experience. I built this, I tested this, broke this, and rebuilt it. So, this is not theory. This is what worked for me and the people I work with right now. This is not a framework which I got from textbook or anything. It's a system that I built from the field. Agentic workflows built on set have consistently delivered on reliability, consistency, and output for the teams I work with right now. If you have found something better, genuinely, please let me know. We are all figuring this out together, and it would help all of us here to grow and learn. But if you have not, this could be a starting point. It is working and it can work for you too. Then you now you're thinking, okay, Vignesh, what to do next? Here's what I have. One, if you have like a paid Claude account right now, I suggest going and watching this video, which is basically how you connect your Claude code to AutoCAD and building your first skill. So go ahead and give this a watch. Or you're thinking, Vignesh, well, I don't have like a paid Claude account. I'm still not sure whether I have to get one. Here's like a $0 starting point, which you can get with Google Anti-Gravity. It is not as good as Claude Code yet, but it's a good starting point. So you get a feel of what agentic workflows are. You can build your first automation in Google Anti-Gravity as well. I've got like a free one-on-one CAD clarity call as well, where we identify your biggest bottleneck. We map out exactly what to build first, and you can save months, going back and forth with all your experimentation. You can just directly hit on your bullseye.